explain to you with the two-way tables is you're taking a situation, a scenario, and you're making a comparison between these two different types of subgroups of people or subgroups of items. With here, we've got bilingual students. Bilingual meaning that you can speak two languages, right? So we're going to showcase a comparison or an overlapping. You guys have actually seen a representation of two-way tables in a form of Venn diagrams. How many of you have seen Venn diagrams used in your social studies classes a lot? Okay, Venn diagrams is actually another way of displaying two-way table information, just not in a table format. So what this shows is these subgroups, these two categories or two groups, and how they either are separate from each other or how they overlap with each other, or how one is one and the other is another. So here, we're talking about the bilingual student, we'll say that there's people who speak English and people who speak Spanish. So we have Spanish speaking, so either they speak Spanish in the group or they do not speak Spanish in the group. And then we have what's called a total. And then we've got speaking English in the group versus not speaking English in the group. And then again, a total. So this is the setup of your two-way tables. You have information of this is, it either happens or it doesn't, and a total. And then another, either it happens or it doesn't, and a total. Okay? And let's say that we have something like 30 students. There's 30 students who speak both Spanish and English. If they speak both Spanish and English, then it's going to go in the box that is under the Spanish column and the English row. This represents that they speak both languages. Now, if I said that they speak no English and no Spanish, which box is it going to go in? And I'm going to go ahead and put a little number in each box. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have 9 little boxes here. So I want you to think about it. If I say that they don't speak either of the languages, which one of those boxes should I put that information? If I say there are 5 students that do not speak either of the languages, Leah? Box 5. So I'm going to put a 5 right in here. Box 5, they don't speak either of the languages. So it's going to go where they don't speak Spanish and they don't speak English. It combines together here. Okay, it's almost like reading a coordinate grid, right? Let's say that I have a total of 120 students. I have a total of 120 students that I have made this chart about. Where do you think 120 is going to go if I'm saying it's a total of 120? Amy? Box 9. Good. It's where the total is. See, the total represents the entire group. Box 3 represents the total number of English speakers. Box 3 represents the total number of English speakers. Box 6 represents the total number of non-English speakers. 7 represents the total of Spanish speakers. 8 represents the total of non-Spanish speakers. Okay, and then obviously box 2 represents the amount of people who speak English and do not speak Spanish. Box 4 represents the people who speak Spanish and do not speak English. Okay, so that's just the breakdown of how it's going. So if I say there are 95 total English speakers, how do you think I'm going to figure out how many English and not Spanish there are? What do you think I would have to do to figure that out? Subtract what? 30 from 95. Good. So we would do a subtraction of the total amount of English speakers. We would subtract the English and Spanish speakers away from it, and that would leave us with the rest of the English speakers but that don't speak Spanish, which would be 65. Okay? All right, if I say that there are a amount of 20 students that speak Spanish and don't speak English, let's go ahead and fill in the rest of the box. What's going to be the total amount of non-English speakers? 25, right? We would count together the 20 non-English speakers that do speak Spanish plus the non-English speakers that also do not speak Spanish. So 20 plus 5 would give us 25. And then lo and behold, notice 95 plus 25 equals 120. Okay? How about how many total Spanish speakers are there? 50, right? We're going to add the column together. There are 50 English Spanish speakers and 20 Spanish but no English speakers. 30 plus 20 would give us 50 for that total. And then how many total are not Spanish speakers? 70. We would combine those together, and then if you check, 50 plus 70 does equal 120. Okay, so it's kind of like a puzzle that you're piecing together here. Now, based off of the information that's given, sometimes you might have to fill the table in from a scenario that they give you. Other times, you are going to be answering questions pertaining to that scenario. So let's see what you guys can figure out. I'm going to say the majority of students don't speak Spanish. So you tell me, is this a true statement or a false statement? You're going to identify whether it's a true statement or a false statement. If I say that the majority of students don't speak Spanish, so how many total students are there? 120. And how many of those students do not speak Spanish? 70. There are 70 people who do not speak Spanish compared to 50 people who do. So is this a true statement? Yes. So I'm going to go ahead and write that down. This is true. And the reason is because right here, I'm going to highlight that or underline or circle that in green. I'm writing my statement here in green so we know that this is related. That this statement is true because of the 120 students that are in our little group here, 70 do not speak Spanish. And as long as it's more than half, has to be more than half, then it's okay. 70 do not speak Spanish. All right, tell me if this statement is true or false. There are more Spanish speakers than English speakers. There are more Spanish speakers than there are English speakers. Take a look at the information and identify whether that would be true or false. There are more Spanish speakers than there are English speakers. Is that true or is that false, and how do you know? Any guesses? Eric? False? Why?
Because there are 95.
Good. Okay. So he said that this is going to be false, which is true. That's correct. This is a false statement because of this value and this value. The 95 represents the total amount of English speakers, and then the 50 represents the total amount of Spanish speakers. 95 is greater than 50. So English speakers is greater than Spanish speakers in this scenario. So let's write that down. There are 95 English, I don't know why I'm, which is greater than the 50 Spanish. Okay, 95 English speakers, which is larger than the 50 Spanish speakers. All right, let's try another one. The majority of English speakers do not speak Spanish. The majority of the English speakers do not speak Spanish. Is that true or false? The majority of your English speakers do not speak Spanish. We want to know, is that a true statement or a false statement? Here. The majority of the English speakers do not speak Spanish. What do you guys think? True. It is true. Why? What numbers are we looking at? 65 and 30. Okay, so we're comparing for our English speakers. We have 65 non-Spanish speakers compared to the 30 Spanish speakers in our English category. So that is larger than our Spanish and English speakers. Comparing these numbers right here. Okay, so we know that this is a true statement because 65 Spanish English, or sorry, non-Spanish, 65 not Spanish/English is greater than the 30 Spanish English. So our 65 non-Spanish English speakers is greater than the 30 Spanish English speakers. Okay? All right. Relative frequencies, which is essentially a fancy way of saying a percentage. A percentage or a probability, essentially. So we're talking about the relative frequency of Spanish English speakers compared to just Spanish. And we're saying that that is greater than the relative frequency of non-Spanish English to non-Spanish speakers. Okay, that's a lot of information that I'm putting out here for you. Let me go ahead and zoom in so you can get that copied down, and then we'll go ahead and discuss it. So the relative frequency of Spanish English speakers compared to our Spanish speakers is greater than the relative frequency of the non-Spanish English speakers compared to the non-Spanish speakers. So we'll go over what that means in just a moment. All right, so let's go over what this means. So the relative frequency of Spanish English speakers to Spanish. Let's highlight that first. This is going to be the first frequency that we're going to talk about. The Spanish English speakers, I'm going to highlight this information in orange, to our Spanish speakers. So how many Spanish English speakers do we have? How many Spanish English speakers do we have? 30, right? Let's go back up to here. We have 30 students that speak Spanish and English together, okay? So that Spanish English speakers number is 30. Now we need to compare it to the Spanish numbers. How many total Spanish numbers are there? How many total Spanish are there? 50. So we're making a relative frequency of Spanish English to all Spanish, okay? So it's going to be 30 out of 50. Now 30 out of 50 is the same thing as saying 3 out of 5, isn't it? So when you simplify it, you can write it as 3/5. You can change it or convert it into a decimal. 3/5 is the same thing as 0.6. 0.6 is also the same thing as 60%. So I want to make sure that I understand how to write it in all three formats, in fraction, decimal, and percent form, which is what we used to do in our probability unit. Okay, now let's focus on the next relative frequency. The next relative frequency is my non-Spanish English speakers, my non-Spanish, so I'm going to put NS, not Spanish, and then slash, they do speak English though, and we're going to compare it to all of my non-Spanish speakers, so all of my non-Spanish. So how many students in the chart identified that they were not a Spanish speaker, but they were an English speaker? Looking at your chart, how many? 65, right? If we look at our chart, non-Spanish, but they do speak English, that comes together to being that 65. So I'm going to go ahead and put a nice, lovely little star right here. That's my 65. And then how many non-Spanish speakers were there? 70, right? If we have non-Spanish speakers, no other stipulation, it's just non-Spanish, that's our total. So I'm going to put a star here so I know I'm using that value. It's going to be 65 out of the 70. Now when we're comparing them, we're going to go ahead and simplify it. 65 out of 70, they're both divisible by 5. So that's going to become 13 out of 14. 13 out of 14, which comes out to roughly around 0.93 or 93%. Okay, so we want to know, is this relative frequency, is this Spanish English compared to Spanish greater than the non-Spanish English compared to non-Spanish? Is this greater than this? No. This is a false statement. So I'm going to write off to the side here. This is false. Okay? It is not greater. It is not greater. So that involves you actually doing some calculations. So again, relative frequency, it's the same thing as identifying like the probability that this event is going to occur. Okay? Any questions so far? It's pretty easy. I think the hardest part typically comes from you having to fill in the chart. That's always been the issue that kids have every year, is filling in the table themselves and then identifying relative frequencies. So if you are knowledgeable of where the most misconceptions are, it helps to alleviate you making those mistakes if you are aware of where the mistakes are most commonly made. Okay, now let's go ahead and practice giving you a scenario and you filling in the table of information yourself. All right, so given that scenario, I want you to fill in the information that's in here, and then once you fill in the information, you will then fill in the rest of the table via logic. Like, okay, well, if I know this value and I know this value, I can subtract them to get here. If I happen to know this value and this value, I can add them together to be able to get this one, and using that logic piece. Go ahead and fill the table in based off of what you are reading in the scenario, and then complete the rest using logic. All right, so let's start with the very first statement. This very first statement says that there are 150 kids at the camp. 150 kids at the camp. Which one of these boxes do I need to go ahead and put 150 in? Nina? Box 9. Very good. 150 kids. That means it is the total number of kids at the camp is 150 kids. All right, the next statement. The next statement says that 71 signed up for swim. There are 71 students that signed up for swim. Where am I going to put that value? Jair? Box 3. 71 students, total number of students that signed up for swim is 71. So 71 is going to belong here. Okay, the next piece of information. There are a total of 62 kids signed up for canoe. There are a total of 62 kids that are signed up for canoe. Which box is that going to go into, Sarah? Right here? So total number of canoe students. So does that say canoe total? Box 7. So it should go down here, box 7. So it says total number of students that signed up for canoe. Total number of canoe is going to be 62. And then of those students, 28 of them are also signed up for swim. So of the 62 students that they're talking about from canoe, 28 of them are also signed up for swim. So where are we going to put that value? Where's that value going to go? Caden, where do you think? Yeah, box 1. So we're talking about there's 62 canoe students, and of those canoe students, 28 of them are also in swim. So you're talking about canoe and swim together. Canoe and swim together is right here. That's 28. So it is going to go in box 1. Okay, so now the rest of this is going to be filled out by using our logic that we know that if there are 71 total, and of that 71 total, 28 of them are canoe and swim, then we want to figure out how many are swim and not canoe by just subtracting. We're just going to do 71 minus that 28. And 71 minus 28 is going to give us 43. So we'd fill this in for 43. Okay, I can also fill in this box right here because of the fact that I do know that there are 62 total, and part of that total is the 28, so I can just subtract. I can do 62 minus my 28, and 62 minus 28 is going to give me 34. I can also figure out this value right here by doing some subtraction. I can take 150 and subtract the 71. 150 minus that 71 is going to give me 79. And then I can also subtract these two values to fill in this box right here. So I can do 150 minus that 62. 150 minus the 62 is going to give me 88. And then there's all sorts of things that I could do to get this last box. I could do 79 minus 34, or I could do 88 minus the 43. Either way, it's going to come out to a 45. Either one of those will come out to a 45. Okay, So like I said, this is probably the hardest part that students have every year, is given this information, they have to fill in the box themselves or fill in the two-way table themselves. That's the part that they have the most difficulty. And doing the relative frequency, knowing which values to utilize with that relative frequency. So I'm going to ask you a couple questions about different relative frequencies. What is the relative frequency? And I want you to tell me in simplified fraction, decimal, and percentage. I want it in all three formats. What is the relative frequency of canoers to swimmers? So let's start there. Let's start with the canoers to swimmers. So how many canoers? How many canoers do we have? 62, yeah. We've got a total of 62 canoers. And we're going to put this over the number of swimmers that we have. How many swimmers do we have? 71. So it's going to be 62 over 71. You always want to check to make sure and see, can you simplify 62 over 71, which it cannot be. So that's as simplified as it's going to get. So then you're going to go ahead and convert it into a decimal. As a decimal, it's going to come out to, and we'll round it to the nearest tenth. It's going to come out to 0.87. As a percentage, that would be 87%. Okay, why don't you guys try a couple of these on your own. Relative frequencies. I want to do swim canoe to not swim, not canoe. Find the relative frequency for swim canoe compared to not swim, not canoe. And let's do the relative frequency of not swim, to not canoe. Find those two relative frequencies. All right, let's go over this real quickly. The swim canoe compared to the not swim, not canoe. How many swim canoers were there? Swimmers, canoers together are there? Huh? How many swimmers and canoers together? 28. Swim canoe together is going to be 28 compared to how many are not swimmers and not canoers? Not swimmers and not canoers. 45. There are 28 swim canoe versus 45 non-swim, non-canoe people. That cannot be simplified. So when we go ahead and find it as a decimal, it's about 0.62, which is about 62%. Okay? Not swim compared to not canoe. How many do not swim? How many people do not swim? Look up here. How many people do not swim? 79. There are 79 people who do not swim. These people don't swim. These people don't swim. That's a total of 79 people who do not swim. So that is 79 compared to how many people do not canoe? 88, right? We have 43 people who do not canoe, and we have 45 people here who do not canoe, for a total of 88 people who do not canoe. So we have 79 over 88. That cannot be simplified. When we convert it, it converts out to 0.8977727, and it just keeps going. That's going to round to 0.9. Okay, because that's 897. That 7 is going to make that 9 rounded up. So it's going to be 0.9, which is about 90%. All right, and then the last question that I want to go over. There are 195 males and 126 females in 7th grade here. A survey showed that 110 males and 84 females ride the bus. Okay, so let's go ahead and fill this information in. Let's first talk about the 195 males. 195 males. Is that going to be males who are on the bus, males who are not on the bus, or males that are a total? Total, right? Males total, 126 is going to go here. Then we have, sorry, not 126, 195, my bad. 195 is going to go here. Then we've got 126 females. Where is that going to go? Female what? Female total, 126. Okay, now that's kind of nice because I can go ahead and find the total, can't I? By adding those together. I could do 195 plus that 126, and that gives me a total of 321 students for 7th grade. Okay, now the rest of the information that's been given to me. There are 110 males that ride the bus. 110 males that ride the bus. So I'm going to put this where? Tell me my categories. What are my categories going to be, Aaliyah? Yeah, box 1, bus male, right? Male bus, bus male, whatever you want to call it, box 1. That's where you're going to put it, 110. Okay, and then we've got 84 females that ride the bus. So where's that going to go? Box 4, right? This would be the 4th box, 84. That would be females that ride the bus. Okay, and then you would fill in the rest of the information. We could do 195 minus the 110. That's going to give us 85 males that do not ride the bus. We can do 126 minus the 84, and that's going to give us 42 females that do not ride the bus. And then we would just add these columns together to be able to get the bottom column. So 194 and 127. If you combine those together, it would still equal 328. Okay? You have a quizzes assignment that's going to be given to you tomorrow, as well as a quiz. You will have about 20 minutes to work on the quizzes assignment, the activity, to just get your brain refreshed, and then you will take your actual quiz. So make sure you're looking over how to analyze information, how to create the boxes. You are going to, I do have a green sheet that if you would like to take it for practice, I will post the solutions to it tonight on Google Classroom. So this is just to give you practice. It's not going to go for homework grade, but if you think that I need a little bit more practice filling in table information, then take one of these sheets. It's up here for your use. I will not judge whether you take it or not. So pack up.